So good evening, and thank you for joining us this evening. You're very welcome. My name's Angus Armstrong. I'm a member of the CED Executive Committee, and I organise the Tech Talks. All our talks are recorded and available on CED's website, and our YouTube channel, and this one should be available shortly. This is the third of this season's Tech Talks, and I'm sure you'll find it very interesting, because tonight our presenter is Steve Morris, talking on the subject of bagged construction and other building techniques. And do join us for later talks. All of them are around the third Thursday in the month at 7 o'clock. If you'd like to attend, or if you'd like to be added to the mailing list, then if you can drop me an email or admin at CED, then you will be added to the mailing list. So I'm now going to pass the hosting across to over to you, Stephen.
Okay. Well, I suppose firstly, thank you very much for inviting me again. And I think the last time I was talking about rammed earth construction, and I thoroughly enjoyed it myself. So when I was asked to do this one, I sort of jumped at the opportunity, and I thought this would be a great one. And I think the response from the last one was pretty good as well. So hopefully something similar will happen as well. As Agnes had already said, yeah, please, lots of questions at the end. There'll be plenty of opportunity. And if I can't answer, I will try and endeavor to get the answer out to yourselves maybe later on. But just maybe a little background to myself first before I start. My background training is agricultural engineering and instrumentation engineering. I grew up abroad in Africa, and that's kind of, in many respects, where I had really got the heart for working in sort of rural communities. And really, for the last 17 years, I've been involved in working overseas in various capacities, primarily in rural communities in Africa, India, and Nepal. One of the things that led me into this area of interest was the cost of traditional materials like gravel, sand, blocks, etc. And so I started to look at an alternative forms of construction to look to see how I can mitigate the sort of the costs that were being incurred by the local people. And I came across earth construction, and it seemed to fit the bill for me. Sorting out the issues of material costs was a big one, but it also had a huge environmental interest for me as well. Low carbon footprint and low impact, particularly to local areas as well. The other big interest that I had with it was because it was quite labor intensive. What it did mean was that the majority of the cost of the building, because they were using earth instead of gravel and sand, and a lot of cement. So the majority of the costs was actually going back into the local community. That was improving for me, that certainly would improve the local economy considerably. And also just encourage people who predominantly were laborers anyhow to get more involved in this form of construction. As a result, I ended up doing a lot of workshops, predominantly in India. And through that, I started up a small network of people, network on Facebook to try and encourage and get these people together that I had trained, so that there was a form of networking going on, a place where I could provide my workshop manual, some of my other the shuttering designs that I had, other designs and all of that, all in the one place. And that has absolutely exploded I have a Facebook page there, which you can, if you're interested, you can look up. It's Rammed Earth Eco Build Network, and we have now over 12,000 members in it. It's a closed group, and I'm the only admin in it, which is, it can take quite a bit of work, but I have a lot of good people in there from every area of the world, really, which is good because we are then able to provide good technical information from those who are experienced in particular local areas, and to be able to give that technical expertise to those local nearby. So that's actually one of the big things that's happened out of all of this. So that's a little bit about me and my background. So today we're just going to be talking about really a flexible form of rammed earth construction, and it's commonly known as bagged earth construction. We'll look at some of the advantages and some of the disadvantages of that. So bagged earth construction is really an inexpensive building method, and it's using mostly local soil to create structures which are both strong. They are very, very good seismic and have seismic resilience, and they can be quickly built. They can also be built with minimal amount of experience by local people. Very easy to train them, very easy to get them working and get them involved, and doesn't require an awful lot of special skills. So essentially, bagged earth building, what it does, it uses bags. Quite often it's polypropylene bags, such as cement bags or rice bags, grain bags. And there's a new bag which I have started to use, and it's what I would call the vegetable bags, which have a little bit more of an open structure than the other ones. And what is normally done is normally they're filled with soil, and then they're stacked sort of in a similar manner to brickwork, each being tampered down, and as they're placed in position. You then also have, between each layer, you would use barbed wire as strung up between the courses, and this keeps the bags from slipping and adds tensile strength. The walls are then plastered to look much like adobe structures, and there are a couple alterations to traditional methods above, which I have kind of incorporated into my techniques, and these I'll discuss a little bit later on. Rammed earth and bagged earth construction, beyond being more affordable, seems to fill the many sort of other requirements of sustainability. As I mentioned, earthquake resilience, and also they're having codes of construction which are being given to them by many places. Here in the UK, we have that. It's also happening in America and in Australia. The following steps, which I will go through, will assume that the site has been cleared of all the topsoil and the foundations have been poured or have been built. Just a note on foundations. I'm not going to deal with the types of foundations, but I always prefer, whether I'm doing rammed earth or bagged earth construction, I always prefer to use the local methods of building foundations. And there's some really good reasons for this. Local builders have been building foundations in their own areas for centuries, and they have tried different methods, they have tried different techniques, and what has happened is each area has plumbed for a particular type of foundation that works probably best for their conditions. And for the likes of myself coming in, I don't have much of that information, or I may have some misinformation, and it would be remiss of me really to start to tell them how to do a foundation. The only thing that I would say about the foundation is that I would insist on making it strong enough to be able to take the load-bearing weight, because that is something which will be increased because the size of the walls are quite a bit thicker than if you were using blocks. But other than that, I would encourage them to have the foundations built. And also that means that I can arrive on site a little bit later. Foundations take a minimum of 4 weeks. Concrete does a minimum of 4 weeks to reach its maximum strength. So it's good to have the foundations done in place and they're cured before we even start. It saves an awful lot of time, and it also saves me having to come and be there, earlier on. So it cuts down my time on the site. So what we'll do is, what this also does, I find you're engaging with the local people straight away. And also by doing this, you're also instilling an element of confidence that you would have with them. And you're hoping that this is then reflected back when you're actually starting to do the work. For me, that is a big thing. You're using local knowledge, you're using local skills, speeds up the construction time, and it helps to build a quick rapport with people by doing this. So if we start, I'll just go through these by step, and hopefully it's quite a logical way of doing it. So first of all, step one, really, we're looking at the tools and the materials that are required for bagged earth. What you will need are bags, as I've explained the different types of bags. Normally these bags are about 18 inches by about 18 inches by 30 inches. Roughly is about the size of the bags. We have a plastic bucket, quite a large plastic bucket with the bottom cut out of it. And we use this as a filling chute. So you put this into the top of the bag and it gives you a place in which you can shovel your material straight into it. We're also then looking at 4 to 5 heavy duty buckets, which again, you can use instead of a shovel, you can use those to pour the material into the bags. We then need a stitching material. We need a plumb line. We're looking at barbed wire and also just a pair of cutters for the barbed wire. We're looking at a hammer, heavy duty galvanized wire, or what sometimes I would use is 6mm rebar cut to certain lengths. Just basically a knife, some wire cutters, tape measure, a level, a couple rammers or tampers, and a corner guide. And that's basically all the tools that you will need prior to plastering and for building the walls. What you'll need to do is calculate how many bags you'll need. And this figure is a rough figure, which you work out the height and the length of your wall. And the basic rule of thumb is that you need about 4 bags to every square foot. So 4 to 1 is a rough guide for it. Okay, so once we have the materials all together, the site has been cleared, foundations have been put down. We need to have access then to material which we'll use for filling the bags. And the nice thing about bagged earth is that you don't have to be so particular as you do with rammed earth. You don't have to be as particular with the quality of the soil that you're putting in there. The only thing that I would stress is that you want to avoid using topsoil. So topsoil is the soil that will have any mineral bio matter inside it. And you want to avoid this for a number of reasons, because it breaks down, decomposes, and it creates little voids. The other thing about it, it attracts insects, which then get into the into the wall. They eat it. They can also build their nests. So that's the main thing. So you're looking at sand, dirt, clay, gravel, any sort of subsoil that you can get your hands on. Unlike round earth, you don't have to start sieving it and filtering it out to finer materials. So this technique kind of ensures that what you do is you fill the bags to approximately 90% full, and then what you do is you fold the end over and you stitch up the end of the bag closed. So effectively, you're making yourself a block using a bag filled with soil. What I tend to do is I would add some cement into the mix, and I do this for two main reasons. If you're in an area where you might have a lot of termites, they don't like cement. So there's no chance that termites will actually decide to come and start to excavate inside your own wall. The other thing about it as well, it helps to give an element of solidity with it as well. So if it's well mixed up, it's giving you once it starts to set, it then gives it its strength and it holds the shape. So once these bags are filled, they're roughly then all the same size, which again is something which is quite important. So we step 3, really, we're sewing up and stitching the bags closed. We fold the bags over, and we then start to for the lower bags, foundational side of the bags we would tend to use just the stones. So you would have a selection of these where you just use small gravel and stones inside the bags. You would lay these down, maybe two side by side, so it gives a thicker base to it. And you build this up a number of levels high. So this is a point where you might have, if you're in a slight flooding area, so it protects the rest of the wall from any ingress of water. So that would be the first layer, or first maybe 2 or 3 layers will be made from gravel-filled bags. When you are building this as well, you need to take into consideration how long each of the lengths are, which have not got any internal walls. So if you do have a long straight wall, you're going to need to put pilasters along it. Okay, these are external pillars, roughly 4 to 5 meters spaced out along the wall. And this will be in a place where there are no internal walls that will help to provide a form of stability. And that stability is there required because when you come to put your roof on, you're going to have some lateral forces applied from the actual roofing structure and the weight of the roof. So that's something that you need to take into consideration. So once you've built that level up, you are then moving on to the next level. And this is the level in which I discussed earlier, where you're mixing it with a subsoil and with a bit of cement in it. You will need to measure out and know where you're going to have your windows and where you're going to have your doors. So you will have to make some frames up and put these frames in a place where these windows and where the doors are going to be. You will then just build away with your bags as you would normally build, so they would be overlapped a little bit each time. And when you come to put your end of your bag in up against one bag, you put it up nice and firmly, get it lined up, and then lay it down. And what the technique that I would use with this is that I would work all the way around to do a complete course. And then after that complete course is finished, that is the point in which I would then start to tamper, and that's to pound down the bags. And the reason for this, it then means that the bags then push against each other. They create a bit of resilience against each other. The joints are then tight, and it allows the bag to then also curve down over the bag, which is above it. So it forms a slight curvature. This then just helps with a bit of interlocking, an interlocking system. So we moved on. Once we've done one layer and it's all been tampered down, you would then have 2 layers of barbed wire, which you run along the top of this layer. And I would then, you work that all the way around, and you hold it down with maybe some blocks or something heavy just to keep it in place. And you would then start your second layer on top of that. And you would start from the corners or from one of the windows, one of the window frames or the door frame. And you work backwards from each end, and you work in towards the middle. Obviously, what you will then have is you might end up with if you're lucky enough, it fits in perfectly. If not, most likely you'll end up having to make a small bag. So you get a bag, you fill it sufficiently, which will fill into that gap that you are left with. Again, you can just fold this bag over because it would be excess material. Or you can cut it and stitch it if you prefer. Put it into place and then tamper it down all the way around. And you just then repeat this process all the way up to the very, very top of the window levels and the door levels. So once you've got to that level, what you have is you are now at a level in which we're looking at making a shuttering in which you'll be able to pour a ring beam. So at the top of the window frame and the door frame, you will then have a shuttering system which will be approximately 6 to 9 inches deep and the width of the wall. And also it will come out and join onto any of the places where you have the pillars, if you have some outside pillars, or if you have an internal wall which is coming in as well. The shuttering will go all the way around that in order that the ring beam ties in all the walls together. The purpose of this is, as I said, is to tie it in, and it will be reinforced with rebar as well. But it will also give you a platform in which you can actually put your roof structure on top of this ring beam. One of the things when you come to tampering, I would lightly tamper all the way around. And the idea behind this is, first of all, you're looking for any slightly raised areas that you will have, and bring them down to almost the same level as everywhere else. And then you're slowly working along. And the idea is to try and get it as level as possible. It just makes it easier for each level to be built on top of that if you have a good straight level that you have just completed. One thing that also needs to be mentioned, which I forgot to mention, is the lower level where the gravel bags are made. They go in, they're built in, they put in the normal way the bag comes to you. For the next levels with the soil, what I tend to do is I turn the sack inside out. Initially, I didn't do this, and what I found was I ended up with bag ends poking out. So by turning the bag inside out, you've suddenly created a little pocket where the corner of the bag is forced inside. You fill this up and you suddenly end up with a much neater, straighter wall. And the joining, you have a little tiny bit of a cavity between the bags, which help with interlocking when you come to do plastering. So that was something which I found afterwards, which made it look much, much tidier. So that's the tampering. And now if we move on to, we talked then about the ring beam on the top. What I would like to do is maybe just show you a photo of what can be done with the corners. So you have an overlap with the corners on the building. And this can create quite an interesting outside effect, quite aesthetic as well. It also can create a little sort of a cubby, little seating area between them. And I have a photograph here in which you'll be able to see. What I'll do is I'll just, because I'm using a laptop and my phone, I will just move my phone and let you just have a quick look at this here. Just give me a second. Can you see that okay? Yeah. So you can see here where these pillars are, and this here is a corner. So that wall continues on out here. This wall continues on there. That gives you a lot of stability. We have a pillar here because of the distance between this wall and that wall is quite considerable. So there's a pillar put in here, a pilaster. Now this area here, it just creates a nice little sort of outside cubby area, and also obviously a bit of protection as well from the wind by having these built out. You can also see where the concrete lintel or plinth goes out all the way out onto the pillars along the wall, but then also out onto the pillars. Now this also provides an area in which some, the roofing structure can actually overhang. It can give an area which is protected both from the weather, if there's rain, etc. And same with like here, this post here provides a bit of protection for the door and the entrance. Also, if I just show you this picture here, you can see this here is the ring beam, reinforced ring beam, and you can see, so the height of it is there, and that goes all the way around and across even on the internal walls, which have also got these pillars inside. You can see how tidy the wall is, particularly here. So the corners of the bags have been tucked in, and this is quite tidy. Now, when we come to plastering, all these little nooks and crannies provides quite a good key to plastering. One additional thing that can be done if somebody is concerned is that they can put a little bit of chicken wire, draped chicken wire over the whole wall, and with the plaster can actually then lock into that chicken wire, which gives an awful lot more structural stability for the plaster, the surface itself. There are two ways of plastering these walls. One can be done with a cement plaster, and this is done quite often for the outside because it's more waterproof and provides maybe a better protection against the elements. But then the inside can be done in earth plaster. It gives you a bit more warmth to it. So there's two different types of plastering techniques which can be used for this. And again, using local skills. I like to use lime plaster, but unfortunately, it's not always readily available in different areas. And also the skill of lime plastering is something which is quite often has been lost with the advent of cement and sand. And so therefore it's just easier just to acquire the cement and to get a plasterer to come and to plaster the building in the normal fashion. So I hope that's that there has been fairly clear with that there. Now, there have been some questions about use of the poly bags, rightly so. Many of us will have a look and we'll see poly bags lying around in different places, and they're breaking down, and you try and grab hold of one and the whole thing just disintegrates in your hand. And the reason for this is because they break down with UV light. But once they are covered and they're sealed, there's no light involved in getting to them. They can last, well, according to U.S. Department of Transport, apparently they can last for up to 500 years. Now, I don't know where they get that information from or who's tested it or tried it, but he must be an old man who's done that. But they say once it's out, new bags, if they're out of the way of the UV light, then really there's no detriment effect or weakness to the poly bags at all. Now, while we're on the issue of bags, these bags, cement bags are quite readily available. Now, some of you will have, if you've listened to my last talk on round earth, I try to avoid using metal, steel as much as possible. So when the traditional way of doing bagged earth is by using barbed wire between the layers. Now, again, it's just something which kind of goes against my grain. It's also quite costly. There are also places where you can't get barbed wire. So again, sourcing it can be a bit problematic. So what I looked at this issue and I tried to find a solution to the problem of not having the tying effect that the barbed wire has inside the walls. And so I came across another type of bag, which is a vegetable sack. And these have a much more open weave to them. And what this has actually done, I find, is that it allows the material that's inside the bag, which will be slightly moist. It has a bit of cement in it. It's a soil clay in it. And it allows it to protrude. So when you put the bags on top of each other and you're ramming them, you have a fusion that's happening between the actual material inside each of the bags. And I have found with experience that this has produced an interlocking system. And again, once these bags are covered and protected, there's no breakdown without any UV light. And so I started using that. What I have then done is used a little bit of rebar in different places where I felt that maybe I needed to put a little bit of strength down. I would then have lengths of rebar and I would drive them down the wall through the bags, which would help to interlock. And rebar is readily available far more than barbed wire. So that's something that I have sort of changed away from maybe the traditional ways of building with bagged earth. The type of soil that you're looking for ideally is something which has got about 30% clay and about 70% sand and gravel. And that there is recognized as that's the maximum sort of strength, bonding strength that you will get from a soil. And by adding a little bit of cement to that, which would be maybe between 3 and 5%. Some places like to use a bit more, but 3 to 5% is quite sufficient. Earth bag structures provide an additional aesthetic and interesting form of construction over rammed earth, which has to use shutters. And by this, what I mean is that you can now start to use almost any shape. The bag earth means that you can actually start building with curves very, very simply. So you can have a free-flowing shape to a building. Now the curves, anybody who knows anything about curves actually create a strength as well in themselves. So by instead of working with just straight lines, one can start to look at having curves and round walls, S-shaped with a bend in them, and it just creates something which is a little bit more interesting, and dare I say it, a lot more fun to work with as well. Lime plastering is something which I would advocate because it has much lower CO2 emissions compared to the cement, the impact that cement has had, particularly on our environment. But it's a lot more difficult to get people who know how to do that and who are used to working with lime. But also, it's also a lot more difficult to get hold of the right type of lime for that type of plastering. I have one more photograph which I'm just going to show you, and it just gives you a little indication. Now, this is a round building, and it has entrances to it, so you can see where the framework is put in for the doors, and you can see how the bags are laid down on this. Now, this here is, instead of using small bags, it is using a continuous long sack. It's not a building that I have done, but it is a building which I had come across and I'm quite interested with. So I'm just going to show you that, if you can have a quick look. So you can see here, these are the frames, the door frames, and you have a nice round curved walls, and these curved walls are all pushed up against the door frames, and it's a very, very strong and stable effect. You can actually see in here, there's water pipes being placed in here. There's other things here. There's also a DPC. So that's a waterproof membrane which is being placed inside there, and then the gravel has been placed on top of that, so that DPC goes up to quite a high level up there. So that kind of gives you an idea of a structure, or like a structure in which it's you can just play around with any shape that you particularly like. Just give me a minute here. There we go. One of the things that has also been happening recently in the UK, what we have started to find is that we have now started to get some regulations being made for earth construction. That's happened since about 2012, or sorry, 2006. And bagged earth has also kind of tagged itself along on with that. What you'll find is that there is very little work being done. It's not something which is sort of being grabbed hold of in the UK, and maybe a little bit more in America, in the southern areas of the States. There is a bit more of the bagged earth, sort of super adobe sort of structures that are being done. But the nice thing about this, if anybody is really interested in this, you are going to be sort of at the forefront. This is the early stages of much of this sort of construction, and it's fun. It's fun being there, and there is a growing interest in all of this. One of the things that I would say about bagged earth over rammed earth is that bagged earth is probably a little bit less versatile for a cooler climate than rammed earth. So bagged earth lends itself to the hotter climates more so. And that is something to take into consideration if anybody is sort of involved in any development work. That bagged earth particularly is good for the hot climates. And that's just one particular big advantage with bagged earth. So there's a lot of things that advantages, interests with this sort of construction. Again, it's quite simple, quite straightforward. It's something which can be picked up very, very quickly. It can be taught without a lot of technical know-how. That lends itself to, particularly to developing countries where many people are learn from watching, and they, involved in actually seeing how something is done, and they end up copying that. So it lends itself very, very well to that. So I don't know if there's, I think that's probably really most of what I would like to share about bagged earth construction. There's, if maybe there's some questions, I'll leave my my Facebook page for you, for all of you, if you're interested, and you can have a look at that, and you can maybe join and come on board and see what information we actually have on that Facebook page. So I'm open now to any questions, and I'll see if I can answer them.
So, Stephen, thank you very much. Another very interesting talk, and I'm kind of itching to get out there and build something curvy and groovy in my back garden.
Yeah, a man cave.
Yeah. Well, yeah. We've got a few questions here, and I don't want to hog that. And I've got a oh, you can't see it. I've got a page of questions. But if I could ask, because it's this idea, and maybe it's a general perception about durability.
Yep.
Both rammed earth or bagged earth. What about, if I want to build something on the west coast of Scotland with wind-driven rain?
Yeah.
I don't live in the west coast of Scotland, but I just, that seems like a pretty extreme environment to me. What are your thoughts?
Go for it.
Okay.
When you think about it, bagged earth has been used by the military for a very, very long time for very good reasons. It's used in flooding areas because it is actually very resilient to flooding. It stands up well to it. When it comes to driving rain, rammed earth is no problem at all. What we're looking at, 30% clay content.
Mm-hmm.
Now, anybody who knows anything about clay will also know how sort of a waterproof material it can actually be. And I was involved in a project in 2012 in South India. Now, in South India, they have two heavy monsoon seasons. Well, one particularly very heavy one, and then another shorter one. But I mean, the short one is nearly about 5 weeks long. And this project, the agreement with this project was that I would teach them, train them, we would build the walls, and they were to actually build the roof and put the roof on. To this day, they haven't completed the building. They never put the roof on it. As an engineer, I was quite frustrated because, you have an unfinished project. But after a couple of years, I suddenly found out I was taking one or two people up there to answer this particular question that you've just asked, Agnes. And I had a structural engineer go up one day, and he was talking the whole way up there, asking this question, that question, everything else. It took about 35 minutes to get up to the site. And when we got up there, we had a quick look at the site. He then suddenly all of the questions that he had almost just seemed to disappear and evaporate, because what he saw in front of him was this structure that had no protection whatsoever, had been standing out against all the elements all year round for about 5 years. And he could not see any detrimental effect to the structure of the wall. And that is a massive, one big, long, heavy monsoon season, and then a shorter 4 to 5 week monsoon season.
No kidding.
So that, for me, that was really good. But also the fact that if he was a structural engineer, and I got him to write up a report for me and look at it over a period of 2 years. And there was no change whatsoever that he could actually see. So I've actually found that project turned out to be a real blessing in disguise. And it's answered one big question that a lot of people ask. And also, one of the things is we need to be aware of as well. There are structures all around Europe that have been around for 200 or 300 years, and they're still being used today. And these are earth, round earth construction, and they weren't using any consolidating material in it like cement or lime, so it was just pure round earth, and they're still very stable. So.
And you seem to suggest that the bagged earth was better for the warmer climates. Why was that?
Well, it's to do with the thermal capacity on them. The round earth just seems to have a broader thermal capacity range, and so it's quite good for very cold climates as well. It will hold the heat and use it as a sort of a storage radiator, much better than a bagged earth would. I think primarily the reason for that is because bagged earth tends to use a lot of stone, so you've got a very, very dense, hard material that's inside it, and that's going to absorb the heat and will actually then dissipate the heat much, much quicker.
Okay. Well, I don't want to hog the discussion with my questions. And Stephen Burgess had asked a number of questions earlier on. Someone asked about the proportion of cement to soil, but you've suggested 3 to 5%.
Yeah.
Moisture content of the soil in the fill bags?
I tend to look. We're looking at an ideal thing between 18 and 20%.
Okay.
Moisture content. So it's if you were to dig down 3 or 4 feet into the ground and take that soil out fresh, that subsoil fresh from there, you will have about 18%. Obviously, it depends on where you are in the world, but you'll have an 18%, 20% moisture content, which is ideal. You're looking at having a dry mix. So if anybody has laid maybe a patio and you're looking at having a mix laid down under your slabs, it's like a dry mix that goes down. So.
And Stephen's also said he imagines that plaster thickness and volume of plaster would be greater than a rammed earth block wall, and so cost more. Yeah.
Yes, that is correct, because as you can see, your walls are not as smooth. With rammed earth, I actually tend not to plaster the outside of the wall at all. I would spray it with I would water down some PVA glue, 1 part PVA glue, 20 parts water, and I spray that over the surface of a rammed earth wall. I like the aesthetic look of a rammed earth wall, and with the stratas on it. So actually, I tend not to plaster at all. The inside is different, and people are looking at maybe painting the inside or whatever. So they would plaster the inside. That's a different thing. But the wall is straight with the rammed earth wall, so the plaster is going to be thinner. On the bagged earth, it's going to be a thicker plaster. But again, you're not having to be a plasterer to do that with the rammed earth, because if you look, you can use your hands. So it's a little bit more organic. But yes, there is going to be a lot more material involved.
Incidentally, if anybody else wants to ask a question, if you can stick a hand up. I think reactions down at the bottom of the screen. If you move your mouse to the bottom of the screen, you can see you can raise your hand. Just do that. I'm picturing kind of plastering or rendering onto plastic bags, and just imagine it and all just drop off again.
No, not necessarily. You have a lot of crevices there. So what you're doing is as with any plaster, you tend to put a thin layer on first. So you would be pushing plaster into the crevices between the bags, into the joints, and then you would add another thinner layer on top. What sometimes we would do is add, as I mentioned, chicken wire. So you would attach very fine chicken wire to the outside of that, and that helps to give you a bonding. But there is the bags that I was talking about, the vegetable sacks. They have a much more open weave.
Yes.
And so therefore that I find, again, for plastering purposes, that is much better.
So am I right in thinking, the little bags you get in Tesco's of tangerine oranges?
Yeah.
It's a little bit like one of those, sort of like
not dissimilar to that, but they're about 50 kilo for weight wise. So.
Rob Wakeling has asked, where have bagged earth buildings been built? In Africa? ? You might
where?
But
yeah, there's actually been quite a lot been used in East Africa. There's also some being built in Ghana, so West Africa. So it's not an unusual sort of thing. There's also been one built in just on the edge of the Kalahari Desert. I was kind of a little bit involved with it. I wasn't there, but I was giving some advice on it. And that's somebody who had been working for an NGO in South Africa. And then he decided, when he was retired, kind of finishing with them, he wanted to go back to his home village, and they wanted to build a house for him. And all that they've got up there is basically sand. So we showed him how to build a bagged earth building, but they just used sand. So just filled it all up with sand.
Oh, well, that's interesting. So you don't need clay.
No, that's a nice thing about it. You can use any rubbish material that's around. Just try to avoid having any biomatter inside the bags.
Because you did say ideally 30% clay, but actually, if you haven't got it, don't worry.
No, the military use bags filled with sand for their lookout posts for a good reason. They're very strong. They're bulletproof. They're easily to move. They're easy to pack. They stand up well. So what we're doing is basically doing something similar to that, but then putting some form of permanence, a bit more of a permanence in it. Yep. There was an NGO in I can't remember which country in Africa, but it's West Africa, where they got Coca-Cola, Fanta, and Sprite bottles, and they filled these up with sand, and they used these as building blocks, and then they just plastered over the top.
So did they lay them kind of?
Well, when you look at the shape of the bottle, they kind of interlock slightly.
Yeah.
So you'd have two bottles width. You'd put the nozzle end on the inside, and it would just overlap like this. So the bottom round end was at the back.
I like it. So does anybody else have any questions? Please do speak up if you do have questions.
Yeah, please do.
If I keep talking and you have a question, just butt in. Just stick your hand up, because I will then pin you, which means it records better, basically. But yeah, please butt in. How would you like? Oh, wait a minute. Here we are, Stephen Burgess. Right, I'm going to.
I hope you can hear me. I was wondering about the comparative cost, Stephen, of bagged earth with you start off by saying it's been much cheaper than blocks. Any thoughts about comparative cost of
Okay.
a building? A big question, really. But anyway.
Yeah, Stephen, that's really quite a sort of it's a difficult one to answer, and the reasons for that, you'll probably understand this, is material costs vary considerably depending on where you are and where you're doing your work, how far you're having to import those material costs. So when you think about bagged earth, you are using local material, which is there. Quite often it's free material apart from labor movement. So the cost there is considerably less when it comes to the material side. The slight offset to that is that it's more labor intensive, because everything is about labor when it comes to building with rammed earth and bagged earth. But my argument has always been that I'd much rather pay a bit more money into the local community. They're benefiting from it, rather than paying it to a corporate company outside. But I mean, that doesn't really answer your question directly, but it does depend locally on how much your cement is, how much your bricks are, how much your blocks are, how much you pay for a plasterer, a skilled builder and a skilled plasterer. Their labor costs are a lot more than an ordinary laborer as well. So that's, it does depend on where you are.
Thank you, Stephen. Alan Chadbourne, I think you had a question, and I've muted you, so you just unmute yourself.
Yes, well, it was on the proportion of sand, because where we were near Katakwi in Uganda, we couldn't use sun-dried mud blocks because it was too sandy. So we had to use termite hill.
Yeah.
So and that worked well.
Yeah, a lot of clay in it.
Oh, is that what they do? Well, can you? So we'd be able to use just ordinary soil and not the termite hill then.
Yeah. See, the termite. What you'll find is the termite hill has got a number of things. It's a subsoil, but also termites will pass it through their body, excrete it, and they end up with this. It's like has a natural binding fluid, which they spit it back out, and they're kind of munching it and spit it back out, and so they've created this saliva, and it bonds. And of course, what you're doing is you're crushing that down, breaking it down, add a little bit of water to it, and you're reusing basically what the termites have done to build this incredibly strong structure.
Except that once you've made the blocks from it, dried them, they're not resistant to rain like the termite hill is.
No. Did you add any cement to it?
For some of them, but not for most of them. No.
Okay. So, yeah, what I tend to do is I would add. Now, obviously, if you're using a lot of like sand, if we talked earlier, Angus, there that in an area where there's just pure sand that you're using in the bags, there's no point in putting cement in it. But if you're having a mixture which has got some soil in there, you've got sand in there, you can add the cement. And I tend to use sort of about 3 to 5% volume of cement into the mix. That helps. Now, the resilience, when you say about the blocks, if you were to add a bit of cement into that mixture, that's actually going to give you that strength and that resilience that you're looking for. But then also, if you coat it, you spray over it this a mixture of 1% PVA glue and 20% water. And if you were to do that, spray the wall once a year, annually, it's amazing. Most of the water runs off, but it still allows the actual wall to breathe. So if it does get a little bit of humidity into the wall, as the season changes, it then dries it out as well.
Thank you.
If I could ask, just jump back, just as you were talking there, I thought of something. You talked about tamping.
Yeah.
If I said I was walking along the wall with a cricket bat and giving it a belt as I went, would that be the right sort of thing?
Yeah, that could work. So you use the back of a cricket bat, the flat of a cricket bat, you could do that. So there's a technique which is used where they use a bar like that. The other one is to use a flat weight, metal weight, which has a pole up the center of it, and you're just literally raising it up and dropping it down onto the actual surface itself. So, yeah.
Would you like to comment on mud bricks?
Okay.
Why don't we just use mud bricks?
Okay, mud bricks, they take a long time to prepare. Putting them out into the sun to dry. As many of us will know, if we're working in Africa and Asia, the seasons have changed considerably. And you can't always guarantee that when you are doing it, that you're going to be getting your dry weather that you should have. You then do have to protect and cover them. The other thing about them is some will then decide to fire them. The amount of wood that is used to fire these earth bricks is colossal. Putting aside the whole issue of collecting this firewood, burning the firewood, what you often find is the people who collect the firewood are ladies. The ladies are not being paid properly as they should be. It's the same with when you're having a lot of construction going on, particularly with cement construction. The volume of water is rarely ever put into the cost of the building because the ladies are the ones that go and collect it, and they're not paid really to do it.
I thought you were going to tell us that it was not as good.
No, earth blocks work well. You can have, there are earth block machines where the form is designed where they interlock. So you can interlock them, and that works quite well. It means that then you're not having to use as much mortar in between them, or you can get away with using a mud mortar, and you kind of put a very sloppy mud mortar onto it, slide the block in place, and the water inside the mortar is absorbed into the block very quickly because the block is dry. And if you then don't move it, that locks nicely in place. So no, they do work. It's just there is a lot of more skilled work involved building blocks. You're needing the machine, the cost of the machine to make them, unless you actually just make a little form and you do them. But then again, hugely labor intensive. But a lot of it is this whole thing of making thousands of blocks that you have to lay out in the sun. They take up a lot of space. You'll also get considerable amount of damage from them. So there's an unpredictability about it.
I mean, I haven't seen a great deal of this, but I was in Rwanda earlier in the year, and there were just these mud bricks lying all over the place, and they looked like they'd perhaps got some straw through them or something like that. And they were very coarse. They weren't made in a form. And should I be trying to convince these people to do rammed earth or bagged earth construction? And is it going to save them money, or is it going to give them a superior product?
Well, I think there's a couple things. One, if you've got the time to convince them, as many people know, if you're doing development work, it takes a bit of time to work with local people for them to have a traditional idea, to move from that to move to something which is a bit, is different. It does take a little bit of time, particularly if you're just trying to have to show them. If they can see it, for instance, many of them will look in a city and they'll see the concrete building, and automatically they think this is the best, and we want that. So it's all done for them. So visually it's all there. But when you're going into a community and you're trying to convince somebody, you haven't got anything visual. You have to create that visual building. So it's going to take a bit of time to do that. And also you're having to try to convince the, what I would say, the influencers, the decision makers in that community. So you need to get to know them, and they need to be on your side, really, before you can go too far. Unless you're willing to do the work yourself and allow them to slowly watch you and see what's happening. That takes a bit of time, but yeah, I would advocate rammed earth or bagged earth over blocks.
And if you were making that argument, what are you going to say? What is the enhancement over blocks? How do I sell it?
Well, the thing is, okay, so first of all, you're looking at what they're familiar with it. So you're having to deal with something which they're not familiar with when you're trying to convince them. You're going to have to build a wall, a rammed earth wall, and let them look at that. Now, some of you asked me earlier, how resilient is a rammed earth wall when it comes to the weather? So you're going to have to build that. You're going to have to let them see that. What I would tend to do is build a rammed earth wall and then build a block wall right next to it, and just let it sit there. Let it sit there. Straight away, because the rammed earth wall will be thicker, straight away they will see the substantial strength of the rammed earth wall. The other thing about as well, if you watch when you're laying it out, you would be looking to see which way the sun is rising and setting. And so you face the wall. So one side of the wall is getting the morning sun, and then the back side of the wall is then getting the evening sun. And by doing this, what you can do as well, you can show the thermal capacity very easily during the day at different times. And that is a big thing when people are in a very, very hot environment. Trying to show them a technique which will help them to keep their house cooler and still look very modern. That's the other thing about a rammed earth building. You can have straight lines which look not dissimilar to a concrete building. Many of them are aspiring for these concrete buildings because of the shape, the form, apparently the durability. But if they can see a rammed earth wall there, they can actually see a lot of that is comparable. But then there are advantages with thermal capacity. I just built a building in Nepal where this very issue is a problem. And one of the designs that we've done is with the roof. So I designed a passive flow, air passive flow roof system. It's very, very different from anything else that they have around there. So I had to try to convince the local joiners that actually this was good. They wanted to do and use their local techniques. They wanted to get their own, what they were familiar with. But I had to really insist on them and said, no, this is the design that we're doing. And we've avoided using sheet steel because there is one of the, and I had to try to explain to them, why is your house hot at 2 o'clock in the afternoon? And one of the reasons is because you're using sheet steel, a single layer of sheet steel. So it's like an oven. So we designed this passive flow roof where they basically have almost like 2 layers. So you have an outer layer, you have an inner layer, and you have this airflow that runs up between it. And it runs up to the top of the building and then curves up and out and down. So they're actually working on that now. So I think some of this is, again, you're having to make a model that local people can actually see and let them talk about it. Let them have that journey of argument and discussion around the campfires at nighttime with their own elders, with their own people, with their women, with the men, with the children, all of this. And it needs to continue. It needs to happen. And then just slowly, the thinking starts to change.
Great. Well,
Could I?
please, yes. Now, Alan, just let me pin you. Yeah, go on.
Following that, could we have another session from Stephen about roofs made from local material instead of sheet steel or instead of grass thatch?
Okay.
That'll be one for another time if Stephen's prepared to come back.
Yeah, I would love to. It's interesting you mentioned the word thatch there, because that is something which they had suggested, because they can get a reed in the southeast area of Nepal. It's very, very flat. It's the rice belt down there, so it's very flat, and they have this reed that they can use for thatching.
Yeah, well, yeah, good. We lived for 11 years in Uganda with grass thatch buildings.
Yeah.
And but it's subject to fire, and that's
Yeah.
and termites.
Yeah, subject to fire, subject to termites. The cost is quite a big undertaking to replace the roof. I'm not sure how often you had to replace it in Uganda, but it's, you have to replace it a lot more frequently than you do a tin roof.
Yeah.
It's also quite heavy, and so the roofing structure needs to be quite strong, and hence the cost of the materials for the roofing structure is there. So there are a lot more alternatives, and also it's a very skilled thing. It's a very skilled job.
Yeah, that's true. I made a curved brick roof with sun-dried bricks, single thickness, and 4 or 5 of us could stand on the top. But I couldn't find a plaster which would work without cracking.
Okay.
So some comments on that would be really good.
Well, perhaps we'll keep that for another time.
Yeah.
Yeah.
Okay.
Yep. So if nobody else has any other questions, and please shout now or forever hold your peace. I think we'll probably wrap it up there. It's 8:45 now, and we've run later than we normally would. And Stephen, thank you very much. I mean, it's been a very interesting talk. You can see from me, certainly, I've been full of questions. Very much appreciated your efforts, and I'm sure it'll be of value to people going forwards. So thank you very much. And
if I was just to say one thing there, anybody interested in the Facebook page, it's called Round Earth / EcoBuild Network.
Hang on.
Round Earth
/
EcoBuild Network.
That was one of my other questions.
Or if you look up my name, Stephen Morris, EcoBuild, then we can probably link you through that way as well.
The first pictures you showed us of that house, was that one of yours?
No, it's not. That's not one of mine.
Okay.
That is actually in Nepal, and that building was built just after, before the earthquake that happened, the big earthquake.
And
was that in 17? I think it was the big earthquake that happened in Kathmandu. And what's quite interesting about that is there were about 500 or 600 of these bagged earth buildings were built by a couple NGO organizations prior to the earthquake, and not one of the bagged earth buildings collapsed.
Excellent. And do you think that's largely the ring beam?
The ring beam, well, the ring beam plays a part in there. But what you'll find is with bagged earth, when you're thinking about it, you've got with the bagged earth, the bags are down on top of each other. You have a seismic action that happens. And so therefore there's a little bit of a movement that happens. Now with a concrete building, there is no flexibility whatsoever. It's all solid, monolithic. But with a bagged earth, it's not monolithic. And so therefore you have this slight movement, and that there would have been probably the primary reason why the bagged earth buildings didn't collapse at all.
Right, that's really good.
Yeah.
Okay. I'm going to now stop recording.